Hello everybody, and welcome to exercise 3 on page 30 of the workbook. Let's take a minute to read this question together. So the force on a dam holding back a column of water h meters high is given by F equals G of h meganewtons. Give units for and an interpretation of each of the following statements in terms of the dam. Okay, so this is yet another situation where they're describing a function to us, but they're not giving us a graph or a formula for it. So we need to think conceptually about what this is telling us. Even though we don't have a graph, we can kind of think generally about what a graph might look like. Okay, so I'm going to just draw a picture over here. Notice that we have an input variable h, which represents height of a column of water in meters. And our outputs are forces on the dam, F, measured in meganewtons. I'll abbreviate that just MN for meganewton. Okay, and let's start with part A here. So they're telling us that G of 8 equals 156.8, and they want us to explain what that means. Okay, so let's think about the two numbers in that statement, starting with the 8. Which variable does that represent? That's an input, so it must represent a height. And 156.8 is an output of our function, so that must represent a force, F. Okay, so with those two identifications, notice that we can kind of see what that statement is telling us. It's just saying that if the dam is holding back a column of water whose height is 8 meters, we should be getting a force of 156.8 meganewtons on the dam. Okay, and that's really all we need to say here. So this indicates that the force on the dam is 156.8 meganewtons. If the column of water that it's holding back is 8 meters high. Something like that. Okay, and I think that's part A. What about part B then? All right, well, in this statement, they're telling us that G prime of 8 equals 39.2, so we're talking about the derivative now. We might start by noticing that the 8, that's still representing a height. Okay, we're being given information about the situation where the height of the column of water is 8 meters. The question is, what does the 39.2 mean? Okay, well, remember, that's a value of the derivative. So geometrically, its units should be units of a slope. And looking back up at the top of the page at our graph, that means the unit should be meganewtons per meter, rise over run. Let's attach those. Okay, and those units give us kind of a roadmap as to how we might want to explain this. Okay, so it's just telling us how fast the force on the dam is increasing relative to the height of the water that it's holding back. Okay, so here comes a possible explanation. So, when the dam is holding back a column of water 8 meters high, the force on the dam is increasing by about 39.2 meganewtons for each meter increase, or each meter that the height of the column of water increases. Notice how we incorporated the units into our explanation. Okay, so we had meganewtons per meter up here, and we kind of had that same choice of words down here in the explanation that we wrote.